Take a look at the world around us. It feels perfectly tuned for life. We have a stable, breathable atmosphere, thriving ecosystems, and a predictable rhythm of seasons, reliable enough to set a calendar by. But 4 billion years ago, there wasn't a single blade of grass or drop of water. The Earth was entirely devoid of life, covered in an ocean of boiling magma. Geologists call this the Hadean Eon, named after the Greek god of the underworld. It was a period defined by 6,000 degrees surface heat and a relentless bombardment of massive space rocks. So how exactly does a toxic, molten sphere transition into a world with deep oceans and the highly specific mix of gases required to keep humans alive? Earth's modern stability is the consequence of a 4.6 billion-year sequence of violent cosmic accidents. To see how that sequence started, we have to rewind 4.6 billion years. Before the Earth existed, this space was completely dark, just a freezing, empty cloud of gas and dust, known as a solar nebula. This cloud drifted peacefully until a massive star exploded nearby. The shock waves from that supernova hit our nebula, causing the gas and dust to collapse inward until the immense pressure ignited our sun. The newborn star consumed almost everything in the cloud. Only a tiny fraction, about 0.2% of the mass, was left behind, swirling around the sun in a flat, rotating disk. Within that disk, microscopic pieces of cosmic dust bumped into each other. Driven by simple static and chemical forces, they began binding together to form small clusters in a process called accretion. Over millions of years, gravity took over the accretion process, pulling these clusters together. They swept up everything in their orbital path, slamming together with enough heat and energy to form massive, molten protoplanets. Every rock and continent you stand on today is built from that leftover dust, billions of years of cosmic debris, crushed together by gravity. At this stage, early Earth was entirely dry. The molten surface was so intensely hot that any liquid water would have almost instantly boiled away into deep space. The water we rely on had to be delivered from the outside. Out on the freezing edges of the solar nebula, large comets and asteroids had trapped massive amounts of ice crystals inside their rock. For millions of years during the Hadean Eon, thousands of these icy asteroids plummeted towards the sun, crashing relentlessly into the molten Earth. The sheer heat of these catastrophic impacts flash-boiled the alien ice into steam. That vapor thickened into a dense, dark, cloudy atmosphere, eventually cooling enough to rain back down on the rocky surface. That continuous rain pooled over millions of years, filling the massive basins that dominate our geography. The asteroid bombardment functioned as a delivery system, importing the water that makes up our oceans. As the surface accumulated water and began to cool, the planet entered the Archean Eon. While the crust hardened outside, the interior of the Earth went through a mechanical sorting process. Because the inside of the planet was still molten magma, gravity pulled dense elements like iron and nickel straight down toward the planet's center in a process called differentiation. This created a distinct structure inside the planet. Intense pressure forced the iron at the very center into a solid inner core, surrounded by an incredibly hot, churning ocean of liquid outer core. As the Earth rotates, that swirling liquid iron constantly rubs against itself. The friction generates massive electrical currents, projecting an invisible magnetic field far out into space. That field acts as a shield, continuously deflecting the charged radioactive particles carried by solar winds. If those heavy metals hadn't sunk to the core billions of years ago, the sun's radiation would strip away our atmosphere long before life had a chance to begin. Even with oceans and a magnetic shield, early Earth still needed one more violent shift. Around 4.5 billion years ago, a Mars-sized protoplanet named Theia dangerously shared our exact orbital path. The two young planets inevitably crossed paths. Theia collided with the molten Earth at tens of thousands of miles per hour. Theia was completely obliterated. Its heavy iron core fused directly into Earth's center, while a massive ring of glowing debris was ejected into orbit, coalescing to form our moon. We know this impact occurred because when NASA analyzed lunar soil samples, like the ones shown here from the Apollo missions, They found that the oxygen isotopes and chemical composition of the moon rocks matched Earth's basaltic rocks. The force of that collision knocked Earth off its axis, giving the planet its 23.5-degree rotational tilt. Because of that specific angle, the northern and southern hemispheres receive varying amounts of sunlight as we orbit the sun. This is the mechanical reason we experience seasons. Furthermore, the newly formed moon exerted its own gravitational pull, dragging the ocean waters into tides. These shifting waters forced early marine organisms to adapt to changing environments, eventually providing the conditions needed for life to move onto land. The destruction of a neighboring protoplanet provided the orbital tilt and tidal systems required for the world we live in today. Eventually, the collisions stopped. Earth finally stabilized, the crust cooled, and those vast liquid oceans went to work absorbing toxic carbon dioxide from the atmosphere, clearing the way for oxygen to rise. If that greenhouse effect had been slightly stronger, our oceans would have boiled away, leaving Earth with a suffocating atmosphere exactly like Venus. If the greenhouse effect was slightly weaker and the planet lacked its magnetic shield, Earth would be a freezing, desolate rock exactly like Mars, unable to hold on to its water. Instead, Earth sits in a habitable margin known as the Goldilocks condition. We have the specific mass required for gravity to hold our gases, the internal heat required to generate a magnetic shield, and a precise chemical balance. Our existence depends on this specific sequence of events, from the supernova to the Theia collision, occurring without a single failure. If any one of these accidents hadn't occurred, Earth would be just as barren as its neighbors. Every breath we take is the result of a 4.6 billion-year chain reaction of incredibly rare cosmic events. It took the death of stars and the collision of worlds to build this world. Now it is our duty to protect it.